Hello, welcome to this overview of the SmartEP Advanced Auditory Research Module, also known as AARM. This module is accessible from the protocol menu and can be used to acquire ECOGs, ABRs, MLRs, LLRs, or CABR FFRs. Ready and calibrated stimuli can be imported into the Advanced Auditory Research Module. AARM allows users to customize every aspect of acquisition and stimulation using an advanced yet easy-to-understand interface. It permits the mixing of stimuli when the notch noise masking and auxiliary output hardware is installed, and provides the user access to define times of acquisition by specifying delays and offsets for each stimuli selected. Users may adjust the sampling rate with choices of 40 kHz, 20 kHz, 10 kHz, and for the duet platform, 5 kHz, allowing for the use of even longer stimulus signals. If your system has notch noise capability with auxiliary output channel add-on hardware, you can introduce Ipsi-Lateral white noise masking or other stimuli to the same channel. As shown on the screen, you can activate or check the Ipsi-Lateral channel 2 or stimulus 2 option to present a second stimulus to the same ear, and then select Browse to load the stimulus. IHS supplies the white 40 kHz stim white masking noise file, which can be found in the C IHS Progs StimEP subdirectory. Now let's take a deeper look at setting up your AARM settings. The first item that should be defined is the rate of stimulation. The rate will determine the length of the timeline. For example, if the rate is set to 10 per second, then the total available timeline is 100 milliseconds, the inverse of the rate, or 1 over rate. For real-world usage, and to avoid phase locking with ambient noise, it is recommended that the rate should not be a whole number. For example, 10.9 is better than 10 or 11. When setting the rate, keep in mind that the final sequence of events required by your protocol must fit wholly inside the timeline, taking into account the needed stimulus length, recording time, and interstimulus interval, or ISI. Note that the rate is 4.35 per second, which leads to a timeline length of 229.89 milliseconds, as indicated at the end of the timeline and under the rate field listed as period. The secondary period value given in points indicates the maximum number of data points that could fit in this timeline based on the selected system's base sampling rate. Let's discuss placing items on the timeline. Stimuli, recording area, artifact rejection area, and the definition of 0 can be moved to any position on the timeline. We will launch the Advanced Auditory Research module in the software. Let's select Standard ABR for this timeline example. Let's set the rate of 19.3 per second. For timing illustration only, let's enter the artifact rejection start and end times at 8,000 and 20,000 microseconds respectively. Turn on the right ear, channel 1, stimulus 1, then load a stimulus by using the Browse button to the right of the file field, and set the intensity to 80. Turn on the left ear, channel 1, stimulus 3, then load a stimulus by using the Browse button to the right of the file field. Set the intensity to 80. Stimulus file will be shown as thick horizontal bars towards the top of the timeline, in red for right ear and blue for left ear, with their duration shown to the right of the bar. Thus, the 1000 Hz tone is 5 milliseconds in duration, while the 4000 left ear tone is 1.25 milliseconds in duration. You may place the stimulus anywhere in the timeline by entering a time offset. We will set the time offsets for both stimuli to 5,000 microseconds after the start of the timeline. We will also set our 0 time to 5,000 microseconds and our start time to 2,000 microseconds. Notice that the 0 time is not necessarily the same as the start of the timeline. This is useful when time shifting of the waveform is required. In this example, the zero time is set to the same value as the stimulus offset. In this case, when recording, 0 will be equal to the onset of the stimuli. For this example, the recorded waveform will start 2000 microseconds after the start of the timeline, but before zero time, allowing for 3 milliseconds of pre-stimulus data to be acquired. In the timeline, it can be seen as a thick green horizontal bar capped by a couple of thin vertical lines. If additional data is required, increase the number of points using the Data Points drop-down options: 1024, 2048, 3072, or 4096 data points. New delimited green horizontal segments will appear on the timeline for every 1024 points added. However, these will result in a single plotted waveform. The total duration of the waveform can be calculated by multiplying the number of points by the sampling rate. In this case, 1024 times 25 microseconds is 25.6 milliseconds. Alternatively, the recording time can be extended by changing the sampling rate. The lowest possible sampling rate is 25 microseconds. Higher sampling rate values are typical when using slower timeline rates. Sampling rates must be given in multiples of 25 microseconds. Thus, the sequence for the stimulus is that when the timeline starts, there are no events. Then, at 2 milliseconds, the recording starts pre-stimulus as defined in the data buffer start time field. At 5 milliseconds, zero time is marked as defined in the zero time field, and stimulus presentation starts as well, as defined in their respective time offset fields. At 6.25, the left ear stimulus ends based on its stimulus length. At 8 milliseconds, artifact rejection starts. At 10 milliseconds, the right ear stimulus ends based on its stimulus length. At 20 milliseconds, artifact rejection ends. At 25.6 milliseconds, the recording ends as defined by the offset and the number of data points. So 2 milliseconds plus 25.6 millisecond recording length equals 27.6 milliseconds. Remember, recording length is defined by the sampling rate and the number of data points selected. At 51.81 milliseconds, the timeline ends. If there are more sweeps to acquire, the timeline starts over. The resulting waveform will be a recording 25.6 milliseconds long, with 3 milliseconds of data pre-stimulus and 22.6 milliseconds of data post-stimulus past the zero time. Select Save to save the ADV settings, and then click OK to link them to your control panel. To link the ADV file to a settings file, select Save Settings to save a set settings file. Now let's discuss some final important details. Although the artifact rejection area can be defined by entering the start and end times into the corresponding fields, the rejection amplitude level is defined using the amplifier window. Stimuli can be presented in condensation, rarefaction, or alternating mode. In alternating mode, the stimuli will reverse polarity with every other timeline iteration. Stimuli can be presented continuously by checking the corresponding box for that channel. When using this option, make sure that the start and end of the stimuli are matched to the same level or zero. Otherwise, an unwanted click might occur at the start of each play loop. When using the stimulus generation utility, make sure to activate the overlap window for continuous output option. Up to 2 stimuli per side can be activated for units with a built-in channel mixer, as discussed previously when presenting ipsilateral noise or babble. Any overlap of the signals will be mixed by the hardware. When activating the right-left control panel option, the channels will change denomination to ipsilateral and contralateral. This setting will reactivate the right-left button on the control panel for easy switching. The EP type drop-down list will define the type of recording file to be saved. The most common peak markers for the type of recording selected will be readily available for the waveform once acquired. Here is an FFR AARM example. We have a single stimulus called CABR BA stim loaded into channel 1, stimulus 1, that is being presented ipsilaterally, 40 milliseconds after the recording starts. 0 time is set to match the onset of the stimulus. The recording buffer is 3072 data points long, with a sampling rate of 75 microseconds, resulting in a recording length of 230.4 milliseconds. Note that the rate of 4.35 allows only a maximum timeline of 229.89 milliseconds. As a result, the last point of the acquired waveform will be truncated and set to 0 amplitude. Artifact rejection is set to affect the entire length of the timeline. Thank you for watching this video. There are 4 parts to this video series. If you wish to learn more, Part 1 covers how to acquire FFRs, Part 2 reviews complex stimuli and stimulus options, and Part 4 reviews FFR data analysis. For more information on the SmartEP FFR options, please contact our sales team at sales@ihsys.com or visit our website at www.ihsys.com. If you have any technical questions or suggestions, please contact our support team at support@ihsys.com.